Hello viewers, welcome to today's lecture on switching techniques. So far we have assumed that two devices or equipment are directly communicating with each other, and for that purpose whatever protocol and techniques are necessary we have discussed, that HDLC we have discussed in detail. However, there are many situations where two equipments are not directly connected. So, in such a case they perform communication through a number of intermediate equipment or devices. So, in such a situation the technique that is adopted is known as switching technique, and the switching techniques can be broadly divided into two types: circuit switching and packet switching. In today's lecture we shall discuss about circuit switching. This is the outline of the lecture. First we shall discuss why circuit switching, then in the context of circuit switching we shall introduce to you switched communication network, that is the model that is being used for communication. Then I shall discuss about the circuit switching fundamentals, their advantages and disadvantages, then various concepts of switching that is used in circuit switching, such as space division switching. One application of that is cross bus switches and time division switching, and of course both of them can be combined having space and time division switching. Then we shall discuss about how routing of signal take place in circuit switched networks, and finally we shall discuss signaling in circuit switch networks. On completion, the student will be able to understand the need for circuit switching, specify the components of a switched communication network, understand how circuit switching takes place, understand how switching takes place using space division and time division switching, understand how routing is performed, and finally they will be able to understand how signaling is performed. So, let us consider the first question: how two devices perform communication when there are many devices. Suppose you have got a number of equipments or stations, say A, B, C, D. So, in such a case A wants to communicate with B, C, D, may not be simultaneously, but at a time A wants to communicate with B, or A wants to communicate with D, or A wants to communicate with D. One possible alternative is to establish connection from A to B, A to C, and also from A to D. Similarly, it may be necessary to establish communication from B to C, B to D, and finally C to D. So, you see we have to provide a number of links, and it can be shown that the total number of links required for n such stations is equal to n into n minus 1 by 2. So, that number is very large. For example, here you have got 4 stations. So, you will require 4 into 3 by 2, that means 6. So, if you count you will find that total number of links is indeed 6, 1, 2, 3, 4, 5, 6. So, you have got 1, 2, 3, 4, 5 and 6, 6 links are necessary. So, this is known as mesh topology, and obviously when you have got a large number of stations, this kind of mesh topology is not practical. For example, if you have got 100 nodes, then you will require 100 into 99 by 2, so many links, that means 9 9 into 9 9, so many links will be necessary to establish communication from any node to any node or any station to any station. So, this is not a good choice. So, what is the alternative? One alternative is to use switched communication network. So, whenever you have got large number of devices, as I mentioned, mesh topology is not practical. So, a better alternative is to use switching techniques leading to switched communication network. So, let me introduce to you what we mean by switched communication network. In a switched communication network, you will find end devices. The end devices are essentially computers, peripherals, communication equipment such as cell phones, laptops, PDAs and various other things, and these are known as stations. The switching devices are called nodes. That means we are using some additional devices, intermediate devices known as nodes, and in such a situation some nodes connect to other nodes and some nodes are attached to stations. Let me show you the network. So, here you see these are the end station A, B, C, D, E. These are the end stations. On the other hand, 1, 2, 3, 4, 5, 6, these are communication network nodes. So, these are the nodes and they are used as switches, as intermediate points for communication. How it is done? As you can see, network topology is not regular. So, earlier I had shown you the mesh topology. There are other topologies such as bus topology, ring topology, star topology, like this. Say bus topology is like this. Say you have got a bus, onto that you can connect all the stations. This is your bus topology. So, in switched communication network you do not have bus topology. You cannot use say ring topology, in which the nodes are, the stations are connected in the form of a ring. So, you can see they are each station is connected to its neighbors. Neither it is star like this. So, we find that in this case the topology is not regular. Then it uses FDM and TDM for node to node communication. So, here we find say this node to node communication, as you can see, is shown with different color from this station to node communication link. Here we find that this is narrower and this is wider. Actually this 1 to 2 or 1 to 3, these are node to node links, and these links are of higher bandwidth. Since these links are of higher bandwidth, and to make maximal use of the bandwidth, we use FDM or TDM techniques. We have already discussed about the FDM and TDM techniques and how you can use the higher bandwidth of links that we have already discussed. So, these links are uses FDM and TDM. There exist multiple paths between a source to destination pair for better network reliability. Here we find it provides you a much higher reliability. For example, if A wants to communicate with C, it can communicate through the nodes 1, 3 and 5. But if suppose one of the link is down or one of the nodes is down, in such a case this A can communicate through the node 1, 2, 6 and 4, or it can communicate through 1, 2, 4, 5. So, in this way it can several alternative routes are possible, which increases the reliability of the network, and that is one objective of the switch communication network, so that it provides you higher reliability, providing multiple paths. Here another important feature is the switching nodes are not concerned with the contents of data. That means whatever data is being sent by a station, that is being communicated by the node. In other words, nodes can be considered as dump devices. Whatever is received, that is being transmitted to other node or the destination station. So, either way it is possible. A station will send to a node, and the node will either send to another node or it will go to another station, as it is connected, as it is shown here. And in such a case, the nodes do not modify the information or data. Their purpose is to provide a switching facility that will move data from node to node until they reach the destination. So, their purpose is essentially to communicate the data which is received from one end and send it to another end, connecting to a node or a station. So, this is the basic model of switch communication network, and as I mentioned, there are various switching techniques. These are circuit switching, message switching and packet switching. So, there are three alternatives, and in this lecture, as I mentioned, we shall be concerned with circuit switching, and in circuit switching the communication via circuit switching implies that there is a dedicated communication path. So, I am highlighting this dedicated, and this dedicated is important because without setting up a dedicated link, no communication is possible in circuit switch network. So, dedicated communication path between two stations. The path is connected sequence of links between network nodes. So, it can be a connected sequence of links. That means, it is not necessary that there will be a direct link, direct path. There may be a path through a number of nodes. So, it can be a connected sequence of links between network nodes, and on each physical link a logical channel is dedicated to the connection. So, on each physical link a logical channel is dedicated to the connection. That is another important feature. And the circuit switching involves three important phases for communication. First one is known as circuit establishment, then data transfer, and third is circuit disconnect. So, in the circuit establishment phase, it is used to establish an end-to-end connection before any transfer of data. So, before any transfer of data can be performed, as I mentioned, you have to set up a link, direct link, and some segments of the circuit may be dedicated link, while some other segments may be shared. So, there are possibility of there are two alternatives. It can be dedicated, it can be shared. Then data transfer, transfer of data is transferred data from the source to the destination. Once the link is established, whatever data has to be transferred is transferred from the source to destination through the dedicated link already established in that circuit establishment phase. Then as I mentioned, data may be analog in nature or digital in nature, either is possible depending on the nature of network, and the connection is generally full duplex. As I mentioned, whenever two stations are connected, usually the communication is full duplex in nature. And finally, once the data transfer is complete, circuit disconnect is performed that terminates the connection at the end of data transfer. Signals must be propagated to deallocate dedicated resources. So, whatever node, whatever link was established, that deallocation is done. This is here it is shown how it is being performed. So, here you see the call request signal is going from A through node 1 to 2, then call request also goes from 2 to 4, node 2 to node 4, then another call request goes from node 4 to node 5 for establishing connection from A to C, and then once the call request goes, call acknowledgement comes through the already established path. So, after the call request comes, data is sent from A to C through nodes 1, 2, 4 and 5. So, this is how data is sent, and after the data transfer is complete, the acknowledgement signal comes from the other end, from node C to node A, from station C to station A, and the circuit disconnect is performed. So, this is how the data transfer takes place in circuit switching. And this circuit switching technique was originally developed for handling voice traffic, but is now also used for data traffic. As I mentioned, this circuit switching concept was originally developed for public switch telephone network for voice communication, but nowadays it is also used for data transfer. And as I already mentioned, I am emphasizing that once the circuit is established, the network is transparent to the users. That means whatever data is being sent will be sent, and information is transmitted at a fixed rate without no delay other than the required for propagation through the communication medium. That means after the link is established, there is no other delay involved except the propagation time. The depending on the distance, depending on the medium that is being used, there will be some propagation time. But apart from the propagation time, there is no other delay involved in this circuit switching technique. And as I mentioned, best known example is the public switch telephone network that is being used in communication. So, public switch telephone network is the best example of circuit switching technique. Now, let us look at the advantages of this circuit switching technique. First, as I mentioned, fixed bandwidth and guaranteed capacity. That means there is a end-to-end link, and since end-to-end link is there, the bandwidth is fixed and it does not change. And here the advantage is it gets guaranteed capacity. That means before after the establishment of the link, it knows both the ends know what is the transfer rate possible, and there is no possibility of congestion. Since the links are having dedicated link, so there is no possibility of sharing, no possibility of congestion. And second important advantage is there is low variance in end-to-end delay. There is a constant delay. As I said, this delay is essentially due to the propagation time. So, there is no other delay involved in this communication. Now, let us look at the disadvantages. In this world, nothing is one-sided, there will be some disadvantage. So, the disadvantages are the circuit establishment and circuit disconnect introduces extra overhead and delay. As I have shown, before any data transfer is performed, it is necessary to perform the circuit establishment, and at the end of data transfer you have to perform disconnection. So, disconnection has to be done. So, for both of these will take some extra overhead, and as a result it will involve some delay also, particularly before any data transfer can be performed. It allows you constant data rate from source to destination, and channel capacity is dedicated for the duration of the connection, even if no data is being transferred. That means, if after the circuit establishment, if data is not transferred, and obviously the bandwidth is wasted. For example, you have set up a call, long distance call, and after setting up the call, if you do not talk, even when you do not talk, you pay for the link or bandwidth. So, this is one disadvantage, and it has been found that for voice connection, although the utilization is high, but statistics show that 64 to 73% time one speaker is speaking, 3 to 7% of the time both the speakers are speaking, and 20 to 30% of the time both are silent. So, as you can see, even when in voice communication the utilization is not very high, as you can see it is only 64 to 73%, but for data communication which is burst in nature, this inefficiency can be very high, particularly in most of the time no data is generated, and only sometimes a burst of data is generated in bursty data in this data communication. So, in a typical user host data connection, the line utilization is very poor, and irony is that if whenever an user is not using the bandwidth, others cannot use it. So, this is another important disadvantage of circuit switching. Now, let us focus on the function of the switching nodes, which plays a very important role in circuit switching. Let us consider the operation of a single circuit switch node comprising a collection of stations attached to a central switching unit. which establishes a dedicated path between any two devices that wishes to communicate. And in a single node network or a particular node, we will have these three functionalities. It will have a digital switch which provides a transparent, usually full duplex signal path between any pair of attached devices. It will provide the network interface. It represents the functions and hardware needed to connect digital devices to the network like telephones. So, you have to interface your devices like computers, telephones and modems to the network, and for that purpose some interface has to be provided. And finally, you will require the control unit which establishes, maintains and tears down a connection. So, here is the block diagram of a circuit switch node. So, one node is shown here. Here as you can see, these are the lines through which the stations are connected. So, all the stations are connected in through these links, and through this interface. So, this interface is used for linking a number of stations, and there is a control unit which performs the linking with the help of this digital switch. So, the control unit controls this digital switch with the help of which the interface can be for example, in this case there is a link between say 1 and this is 2, this is 3, this is 4, this is 5, this is 6, 7 and 8. You have got 8 lines, and this 1 is connected to 6, the 2 is connected to 4, and 3 is connected to 1, and then 5 is connected to 7. So, this digital switch connects each pair as best on the with the help of the control unit. So, this is the basic function that is being performed by a circuit switch node. Now, the switching can be done in a number of ways. One is known as space division switching. One technique is known as space division switching. This was originally developed for the analog environment. You know that telephone network was originally used for voice communication, and as a consequence it was developed for analog environment, but subsequently it has been carried over to digital domain nowadays. So, in a space division switch, the signal paths are physically separate. So, physically separate paths are provided for each of these links or paths from one to another. So, it is divided in space. Essentially, it is a crossbar matrix. So, let us have a look at the crossbar matrix. So, here you see you have got inputs and outputs. These are the input lines and the output lines, and it is organized in the form of a two-dimensional matrix. And as you can see, at the crossing of each vertical and horizontal line, there is a cross, and essentially at each cross you have got a electromechanical switch or micro switch. It is nothing but a micro switch. So, on this, with the help of this micro switch, either a connection can be established between a vertical line with a horizontal line. For example, say here 6 and this is 8. So, if this is closed, that means if this cross here it is closed, this micro switch is closed, then a path is established between 6 and 8. So, if at any junction, if the path is closed, if the switch is closed, a path is established between the horizontal line and the vertical line connecting that particular cross. So, you see this is how the crossbar switch operates. However, it uses electromechanical relays or micro switches. So, as I mentioned, the basic building block of the switch is a metallic cross point or semiconductor gate that can be enabled or disabled by a control unit. That means, the control unit performs the function. As I have shown earlier, there is a control unit. This control unit is controlling the digital switch, and digital switch in case of space division switching is a is this crossbar. So, you see the crossbar switch is this is how it works, and originally these crossbar switches are were having metallic cross point or semiconductor gates that can be enabled or disabled by the control unit. And of course, the early electromechanical switches were not very reliable, were bulky, were used to consume lots of power. But with the advancement of VLSI technology, nowadays the crossbar switches can be implemented with the help of semiconductor devices. For example, the Xilinx crossbar switch using field programmable gate arrays is available, and it is based on configurable routing infrastructure. And in this field programmable gate arrays based switches, you can have the high capacity non-blocking switches. I shall explain about what do you mean by non-blocking very soon, and it provides you very high capacity varying from 64 by 64 or 1K by 1K. So, you see you will require, you can have a very big crossbar switch such as 1K by 1K, and that operates at a very high speed 200 megabits per second. Obviously, the data rate is quite high nowadays, which is possible by using this field programmable gate arrays available from Xilinx. Let me introduce the concept of blocking and non-blocking before I discuss the other functions of the crossbar switch. An important characteristic of the circuit switch node is whether it is blocking or non-blocking. A blocking network is one which may be unable to connect two stations because all possible paths between them are already in use. That means, you may have a number of paths. For example, I have shown 8 inputs and 8 outputs. If you are not able to connect a particular pair because all the paths are already used, in such a case we call it blocking. On the other hand, a non-blocking network permits all stations to be connected in pairs at once and grants all possible connection requests as long as the called party is free. That means, as long as the called party is free, the non-blocking switch will allow connection between any pair of stations or inputs and outputs. For a network which supports only voice traffic, a blocking configuration may be acceptable, since most phone calls are of short duration. What I am trying to emphasize here is that a blocking network is acceptable in voice environment, because most of the time people are not talking. That means, the usage is much less. On the other hand, in data applications where the connection remain active for hours, usually whenever we are talking over a telephone line, we usually talk for few minutes and then disconnect the call. On the other hand, for data applications, the connection may remain active for hours, and non-blocking configuration is desirable. What I am trying to tell, for voice application, blocking network is acceptable. For data communication, the non-blocking network is desirable. Now, let us focus on the crossbar switch, what kind of limitations it has got. As we have seen, the number of cross points grows with the square of the number of attached stations. So, obviously, as the number of inputs increases, inputs and outputs increases, which increases exponentially at the rate of square. For example, if you are having, let us assume 1000 input, 1000 output, or 1000 by 1000 switch. In such a case, you will require 1,000,000 cross points. That means, a cross point is nothing but a electromechanical relay or a switch, electronic switch, and in this case for 1K by 1K switch you will require 1 million, that means 10 to the power 6 cross points. So, it is costly for a large switch. And another important disadvantage is that the failure of a cross point prevents connection between the two devices whose lines intersect at the cross point. Let us go back to the diagram of the cross bus switch, which will explain that. Suppose this particular cross point or this switch has become faulty. If this becomes faulty, it may not be possible, it is not possible to connect 5 with 4. So, 5 and 4 cannot be connected if this becomes faulty. So, even when 4 is not busy, the connection cannot be established between 4 and 5 if there is a failure of a fault here. So, that means the failure of a cross point prevents connection between the two devices whose lines intersect at the cross point. So, I have explained that with the help of the diagram, and as another important disadvantage is that the cross points are inefficiently utilized. What do we mean by that? We have seen that for 1000 by 1000 network, you will require 1 million cross points. But are the 1 million cross points used efficiently? Unfortunately, no. Even when it is used heavily, maybe 40 to 50% cross points are used, remaining all the other cross points remain idle. So, only a small fraction are engaged even if all the attached devices are active. That means, even when all the attached devices are active, that means whenever you are acting, that means you have got n square cross points, but at a time when all pairs are connecting, only n cross points remain busy. So, you see n square minus n cross points remain idle. So, that is a large number. What is the solution to this? What is the other alternative by which the efficiency can be increased? And one better alternative is to use multi-stage switches. What is being done here? By splitting the cross bus switch into smaller units and interconnecting them, it is possible to build multi-stage switches with fewer cross points. So, here the example is shown, which is nothing but a small 8 by 8 switch. You have got 8 inputs and 8 outputs. Instead of a single stage cross bus switch, here you have got 3 stage cross bus switches. As you can see here, this is a 4 by 2 switch, 4 by 2, this is a 2 by 2 switch, this is a 2 by 2 switch, these are all cross bus switches and they are interlinked in this way. Now, how many cross points are here? So, if it is a single stage, you will require 64 cross points. So, in this particular case, as we shall see, 4 into 2 8 plus 8 16 plus 4 20 and another 20. So, you will require 40 cross points. So, this is the reduction. If it is a large cross bus switch and if you use multi-stage switches, then the reduction is more significant. So, in the previous example, as I have explained, the number of cross points needed reduces from 64 to 40. And another important advantage is that there is more than one path through the network to connect two endpoints, and this increases the reliability. For example, in this case, suppose 1 wants to communicate with 5. How connection can be done? 1 can be connected through in this path, say from this using this path, or it can be connected using this path. So, multiple paths are existing, that increases the reliability. So, if there is a failure in one path, another path can be used for establishing the connection. So, this is a important advantage. Unfortunately, there is a disadvantage, because multi-stage switches may lead to blocking, and this problem of course can be tackled by increasing the number or size of the intermediate switches, which also increases the cost. That means, although the probability of blocking is reduced, but it will remain in case of multi-stage switches. Let us see how it happens. For example, say we would like to establish connection from 1 to 3, 2 to 4, 3 to 6 and 4 to 8, which is shown here. So, 1 to 3 connection is established in this manner, then 2 to 4 connection is established in this manner. Now, 3 to 6, how the connection can be done? Now, we find that 3 and 4 cannot be connected to 6 and 8. The reason is, from this switch there is no other path available at this moment for connecting 3 and 4 to 6 and 8, because from this crossbar switch there are two outputs, both the outputs are now engaged for linking 1 to 3 and 2 to 4, no other path is available. So, it leads to blocking. So, whenever we are using multi-stage switches, we essentially it becomes blocking, although it reduces the number of cross points. Now, let us consider another implementation based on time division switching. So, we have already discussed about TDM or time division switching, which is essentially based on time division multiplexing, and here both voice and data can be transmitted using digital signals. And all modern circuit switches use digital time division multiplexing techniques for establishing and maintaining circuits, and synchronous TDM allows multiple low speed bit streams to share a high speed line. We shall explain how exactly this is being done. A set of inputs is sampled in a round robin manner. The samples are organized serially into slots to form a recurring frame of slots, which you have already discussed in detail while discussing that TDM, synchronous time division multiplexing. Then during successive time slots, different IO pairings are enabled, allowing a number of connections to be carried over the shared bus. Let us see how exactly it is being done. To keep up with the input lines, the data rate on the bus must be high enough so that the slots recur sufficiently frequently. That means, you have to use high speed for time division multiplexing switch. For example, for 100 full duplex lines at the rate of 19.200 kilobits per second, the rate on the bus must be greater than 1.92 megabits per second. So, the source destination pairs corresponding to all active connections are stored in the control memory. I shall explain how exactly this is being done. Thus, these slots need not specify the source destination address, because it is stored in the control memory. Let us see how it is being done. So, here for example, the simple TDM where without switching is not done. So, in this case 1, 2, 3, 4, 1 is sending data in slot A, 2 is sending in slot B, 3 is sending in slot C, 4 is sending in slot D, and these are the slot A is again taken to 1, and slot B data goes to 2, slot C data goes to 3, and slot D data goes to C. This is the simple time division multiplexing. Obviously, this will not serve our purpose. So, we have to use something in between. The first thing that can be done is TSI. So, TSI stands for time, this time slot interchange. What this time slot interchange does is it essentially does the interchange of the slots. For example, the connection is necessary from 1 to 4. So, the data from 1 should go to 4. So, this data is now in slot 4, then what comes from 2 goes to 1. So, B goes to slot 1 data, then 3 to 3, here there is no change, and from 4 it goes to 1. So, D goes to 1. So, I believe 1 to 4, 1 to 4, 2 to 1, 3 to 3, and you can see D to A. So, this is how it is being interchanged. So, this data is now goes in the proper form. You can see here B, D, C, A. So, you see all the data is going in this manner. So, you find that the data communication is taking place in this manner. O to 1, D to 1, yeah. Okay. Now, how exactly it is being done? It is being done in this manner. So, here you can see the data is coming in slots, then it is stored in some memory. So, it is, and in this memory the writing is done in a sequential manner, that means 1, 2, 3, 4, and then reading is done selectively. That means, here the writing takes place sequentially, reading takes place sequentially. That is how the time slot interchange take place, and data goes from 1 to 4, 2 to 1, 3 to 3 and 4 to 1. This is how it takes place in time slot interchange. Another alternative is the TDM bus switching. So, here we use a high speed bus, and here the data comes at slow speed and then connected to a high speed bus. And for example, at a slow speed, this one whenever this switch is closed, then this switch is closed, 1 to 4. Whenever this switch is closed, 2 is closed, then 2 is closed, this 1 is closed, and this from the high speed bus the data goes from this input and to the output. So, for example, here the data rate, whatever data rate is here on this bus, it will be 4 times of that, because it is doing the time division multiplexing of data, and it is being read on 1, 2, 3 and 4 in this manner, in this fashion. So, it is essentially some kind of asynchronous time division multiplexing that is being performed, but however, it is done in a different way. From a high speed BART, with the help of the control unit, the reading is taking place at different times. So, for at different times it is coming from here 1, 2, 3, 4, and at different times it is being read by 1, 2, 3, 4 in a different sequence. This is how the TDM bus switching occurs. However, you can combine the space and time division switching. So, we have already discussed the space division switching and time division switching, and it can be combined here. So, these are the typical TDM switches, time division switches, and here it is space division switches, which is nothing but a crossbar. So, as you can see here, this interchange can be done with the help of this crossbar switch. Earlier we have seen the crossbar, the interchange was done with the help of memory or a fast bus. Here the crossbar switch does the necessary interchange. That means, from any one of the switch it will come here, and then it can be taken to any one of these switches, any one of these multiplexers. So, here it is a multiplexer and here it is a demultiplexer. So, from any one of these multiplexers it will come here, and with the help of this crossbar switch it can be taken to one of the demultiplexers. As a consequence, it can go to any one of these lines. So, this is how the space and time division switching are combined in implementing the circuit switch nodes. And as I mentioned, the most important application of circuit switching is in telephony, the telephone network. And I have already discussed about the telephone network, which is organized in a hierarchical manner. As you know, you have got end offices with the help of local loop. These are connected to the end stations. So, here you have got the end stations which are connected through the local loop to the end offices, and the end offices are connected to the tandem offices, and you have got trunk lines. These are the lines where we shall use the FDM or TDM techniques, and then the tandem offices are connected to regional offices. So, we see there is some kind of hierarchy. That means, say one end office will connect to a number of stations. So, a number of stations will be connected. Similarly, a tandem office will connect to a number of end offices. So, these are end offices. So, these are stations or telephones you can say, and this is your end office, and this is your, these are all local loops, these are all local loops, and these offices are connected to the tandem offices, and the tandem officer in turn are connected to the regional offices. So, several such tandem offices are connected to regional offices. So, in this way there is a hierarchical network is used in telephone public service telephone network, PSTN, public switch telephone network, PSTN. Now, let us consider the routing operation performed in circuit switch networks. As I mentioned, in large circuit switch networks, connections often require a path through more than one switches. That is the typical property of the switched communication network. And here the basic objective is the efficiency and resilience. What do you really mean by efficiency? Here we would like to utilize the minimum number of switches. Obviously, we would like to optimize on the hardware cost. On the other hand, the resilience wants higher reliability. Higher reliability means whenever, for example, we may decide the switch capacity on the basis of the traffic, average traffic. However, there are situations where the traffic will be above average. How it will be handled with the help of this network, that decides the resilience, or whenever there is some failure in the network. In such a situation, the network should be able to handle maybe with some degraded performance, or say there is a situation when some catastrophic situation occurs, flood or earthquake or something like that, then the traffic on the network suddenly increases, or even when some exam results are out, say only few days back CBSE result was out, and obviously that led to lots of telephone calls. So, network should be able to handle that, and that requires resilience. And for routing purpose, there are two basic approaches. One is known as static routing and another is known as dynamic routing. So, in static routing, routing function in public switch telecommunication networks has been traditionally quite simple and static. Normally, it is very static in nature, and as we have already seen, the switches are organized as a tree structure. And since it is organized in a tree structure, there is a fixed well defined path from one point to another point through a number of switches. And however, to add some resilience to the network, additional high usage trunks are added to cut across the tree structure to connect exchanges with high volume of traffic between them. That means, to have some resilience, some additional high usage trunks are added, some redundancy is added, so that in case of failure, in case of heavy traffic, this can be tackled. However, it cannot adapt to changing conditions. As I mentioned, there may be some changing conditions because of some catastrophic situations or some special situations. So, for these special situations, this static routing cannot perform, and obviously this will lead to congestion in case of failure. Whenever there is some failure, it will lead to congestion. That means, the connection cannot be established between two users. To overcome the limitations and to cope with the growing demands, all providers presently use dynamic approach. And dynamic routing decisions are influenced by current traffic conditions. In dynamic routing, it is not fixed and static, it is based on the current traffic and conditions. So, switching nodes have a peer relationship with each other rather than a hierarchical one. That means, in such a case it is not the hierarchical network. The nodes or switching nodes have peer relationships among all other nodes. They exchange information to find out the conditions, traffic conditions and other things, and as a result based on that the routing is done. And routing is more complex and flexible, and obviously it will be complex since it is not fixed, it is based on the current conditions, and it has to tackle the catastrophic or special situations. However, it has to be more flexible as well. There are two basic techniques used. One is known as alternate routing, another is known as adaptive routing. Let us see how they work. First, let us consider the alternate routing approach. Here, the possible routes between two endpoints are predetermined. So, it is the responsibility of the originating switch to select the appropriate route for each call. That means, in this case based on the busy hour traffic, busy traffic hours, the routes are decided. For example, maybe in the morning hours all the people are going to office or schools, and in the evening hours people are returning from office or schools, and based on that the traffic control is done. The route timings can be set in normal traffic control. Here also something similar can be done based on the statistics or history. It can be decided in the direction of traffic at a particular timing instance. And in this case, in practice usually a different set of pre-planned routes are used for different time periods. For example, in morning periods one route is established, in the evening periods one route can be established, or depending on depending on the traffic condition and different parts, that can be decided based on history and statistics. So, it takes advantage of different traffic patterns in different time zones and different times of day. This is more appropriate in USA. For example, it has got different time zones, and based on different time zones the office hours are different in different places. So, accordingly the routes can be set up in a predetermined manner, and the routing can be done depending on the date and time and hour of the day. Then comes the alternate routing approach. In alternate routing approach, several alternative routes are predetermined and which are used for communication. For example, you can have a fixed route. For example, from A to D, it can be A to through node 1, then to 2, then to 6, then it goes to D. That means it is through the nodes 1, 2 and 6. So, this is fixed alternate routing, but it can be dynamic alternate routing. For example, another alternate route can be say from 1, instead of 1 to 6, it can be 1, 3 and 5, 6. So, 1, 3, 5 and 6. So, this is the alternate route. So, these alternate routes are available. Maybe initially the shortest route is tried, and if there is blocking, then the alternate routes are explored in alternate route approach. On the other hand, in adaptive routing approach, this is designed to enable switches to react to changing traffic conditions on the network, and it allows you greater management overhead. Switches must exchange information, and it has the potential for more effectively optimizing the use of network resources. For example, dynamic traffic management, this is being used by some telephone companies. A central controller collects data at the interval of 10 seconds to determine preferred alternate routes. So, it gathers statistics, then the routes are decided. So, apart from routing, the nodes must send control signaling to manage the network and by which calls are established, maintained and terminated. So, to perform these functions, establishment, maintenance and termination, various types of signals are to be generated. For example, supervisory signals, which are used for, which are essentially gives you the availability of resources. Then address, for example, the different stations, a particular node has some telephone number, that telephone number has to be sent. So, this is the address has to be communicated. Then call information, whether it is busy or something has happened, or network management has to be done, which will give you which is used for the purpose of maintenance and termination. And it can be, this signaling can be done in two different ways. In channel, it can be in band or out of band. Same band of frequencies are used by voice signals are used to transmit control signals, and in out of band it uses different part of the frequency band, but uses the same facilities as the voice channel. On the other hand, in common channel, this is dedicated signaling are used to transmit control signals and are common to a number of voice channels. So, we have discussed about the circuit switching technique, and here it is time now to give you review questions. Here are the 5 review questions. Number 1 is, what are the 3 steps involved in data communication through circuit switching? Second question is, mention the key advantages and disadvantages of circuit switching technique. Third question is, why data communication through circuit switching is not efficient? Fourth question is, compare the performance of space division single stage switch with multi-stage switch. Fifth question is, distinguish between in-channel and common channel signaling techniques used in circuit switch networks. Now, I shall quickly give you the answers of the questions of lecture number 17. Question number 1 was, why are asynchronous protocols losing popularity? Asynchronous protocols are losing popularity because of their high overhead of more than 20%, as we have explained in details. On the other hand, synchronous protocols provide significantly lower overhead. That is why the asynchronous protocols are losing popularity. Second question was, why bit oriented protocols are gaining popularity? Bit oriented protocols allow packing more information compared to character oriented protocols. That is why bit oriented protocols are gaining popularity. Third question is, in HDLC, what is time bit stuffing and why is it needed? The answer is, the presence of the bit sequence 0 1 1 1 1, which is the flag, which is used as flag to indicate the start and end of a frame, may lead to division of single frame into more than one frame wrongly. This problem is overcome by using bit stuffing. A 0 is introduced after each occurrence of 5 consecutive ones in the information field of the frame. This is the last question, what is piggybacking and how it is being used in HDLC. As I have mentioned, information can be sent along with the acknowledgement can be sent along with the information from the other end. That is the that is being used in piggybacking. So, with this we come to the end of this lecture. Thank you.